Hi, welcome back. So in this video, we're going to be covering the longest common substring dynamic programming problem. So let's have a look. So the problem statement is as follows. Given two strings x1 to m and y1 to n, we want to find the longest common substring between the two. So let's have an example to see what that means. Let's say x is dead beef and y is eat beef. Then we have two common substrings here, EA and beef. The longest is beef with length 4, so we should return 4. So in other words, we're trying to find the length of the longest common substring between the two strings. So let's have a look at the recursive definition or the solution of the problem. We define dij to be the length of the longest common substring of x1 to I and y1 to j that ends at xi and yj. Now you might be wondering, have we changed the problem here? And the answer is yes. But the solution to our original problem is still maximum of dij for all I and j. What does that mean? So we're limiting our solution here. We're saying that dij is the length of the longest common substring of x1 to I and y1 to j that ends at xi and yj. So instead of ending at xi and yj, we loop over all the ij's and we find the maximum one of them, and that's actually the maximum substring ending at any xi and ending at any yj. So in other words, if we define dij like this, we find the maximum value of all the dij's, and that's our solution. Now, there's two cases as usual, that xi is equal to yj or that xi is not equal to yj. Now, if xi is equal to yj, then the longest common substring of x1 and xi and y1 to yj is just the longest common subsequence of x1 to I minus 1 and y1 to j minus 1 plus xi yj. So if this is x and this is y and this is 1 all the way to I, and this is here 1 all the way to j, then, and these two elements here are the same, then the longest common substring ending at xi and yj is actually 1 plus the longest common substring ending at I minus 1 for xi minus 1, and yj minus 1. So here is 1 plus 1 because of these elements plus di minus 1 j minus 1. Now what about 2? If xi is not equal to yj, then we cannot have any common substring ending at xi and yj, because remember our definition says that ends at xi and yj. So if xi is not equal to yj, then dij is 0. So if we combine both of them, we get the recurrence dij is 1 plus di minus 1 j minus 1 if xi equal yj, or 0 otherwise. If xi is not equal to yj, then we cannot have a common substring ending at xi and yj. So we simply set the longest common substring is 0. So, and then at the end, we want to find the max, because remember here, this is not our original problem. We want to find the maximum of all dij's, for all I and j. So we have to keep track of the maximum value of dij. So let's have a look at the pseudocode to see how this would work. We let d0 to m, 0 to n, be a 2D array of all 0. And we set the maximum value equal to -1. And this maximum value is the variable that will store the maximum value of dij. Now we go for I equal 1 to m, for j equal 1 to n. If xi is equal to yj, then dij equal to 1 plus di minus 1, j minus 1. Else dij equals to 0. Finally, after we calculate dij here or here, we say maximum value is equal to the maximum of the current maximum value, or dij. So at the end of these two loops, maximum value is going to have the maximum value of all dij's. And so we just return max value. So let's look at some C++ code for this problem. We include IOStream, vector, and string using namespace standard, and we define a function LCS, longest common substring, that takes two arguments, string s and string t, and we define m as the size, n as the size of t, then max value equal -1. And it's basically the same. We're defining a new two-dimensional array here, d, m plus 1 by n plus 1, and all the values are 0. Then we do two loops for I 1 to m, j 1 to m. If si minus 1, again, I minus 1 because C++ indices start counting from 0. So if si minus 1 equal to tj minus 1, then we set dij equal di minus 1, j minus 1 plus 1. Else we set dij equals 0. And finally, we do max value equal to max value or dij, and we return max value. So it's almost exactly the same as the pseudocode, just a few syntax differences. Then we set string s equal dead beef, string t equal eat beef, and we see out LCS, and we end up getting 4, which is the correct answer. So I hope you sort of understood where the two-dimensional dynamic programming solution came into play here, why we've used two-dimensional dynamic programming, why we used that ends at xi and xj and yj instead of just for the first I elements and j elements that like we usually do. So yeah, different dynamic programming questions have different alterations of solutions, and with more practice you sort of start getting the idea behind how to define your dynamic programming table. And once you define your table, you know how to you start getting also with experience how to find the recurrence relation, and finally just code the solution. So that's basically the steps for solving a dynamic programming solution. You define your table, you find the recurrence solution, and you just write the code. And the first two steps are usually the hardest step. The last one is generally, with more experience, you sort of get the hang of it. So I hope you understood this question, and thank you for watching the video.